Welcome to another tutorial video from Tulla Maths. Make sure and subscribe for more. This video we are looking at simultaneous equations with three variables. In my particular question here, my variables are x, y and z. In order to solve simultaneous equations with three variables, we want to basically eliminate one of the variables. So we want to bring it down to two variables, and then we solve them as we would normally with simultaneous equations. So what I normally do is I pair them up. So what I do is I'm going to take the first two equations here and I'm going to group them together. So I'm going to solve them, or I'm going to eliminate one of those variables. So if I write them out, I have 2x plus y minus z is equal to -3. Now you can put the ones in front of that z and y if you want, because we know it represents 1. And my second equation there is x over 2 minus 4y plus z over 4 is equal to 14. Now before I go eliminating one of those variables, I want to get rid of those fractions. So I'm going to try and eliminate those fractions. Highest denominator there is 4 because these are all over 1. And so that means I'm basically multiplying across that line by 4. So I'm just writing a 4 out here to show the examiner what I'm doing. My top equation is staying the same. It stays as 2x plus 1y minus 1z is equal to -3. I multiply the bottom line by 4. So I'm basically just multiplying x over 2 by 4. And that 2 divides into 4 twice. So that's why I'm getting 2x here. I'm multiplying the minus 4y by 4 divided by 1. Well, 4 4s are 16. And 16 divided by 1 is still 16. So that's giving me -16y plus z over 4. And when I multiply z by 4, I get 4z. Divide by 4. So 4 into 4 is 1. So that's giving me 1z is equal to 14 by 4, which is giving me 56. So that's equal to 56. So that's me eliminating the fraction. Now I'm going to eliminate one of the variables. I'm going to eliminate either the x or the z. No point in eliminating the y's because they are 16 and 1. Remember that we have to keep them to the same number in order for them to cancel out. I'm going to cancel the z's because they already have a different sign. Remember, we're always trying to achieve opposite signs here because minus z plus z will cancel out. So basically that's what I'm going to do. I'm going to put a line through it here to state that minus 1z plus 1z is 0z. I'm basically crossing them out. I don't need to write in the 0z. My 2z plus my 2z is giving me 4z. Or sorry, x I should say. And my 1y minus 16y is giving me -15y is equal to -3 plus 56 is giving me +53. So now I've got it down to just two variables, x and y. Next step I'm going to do is I'm going to take another pair of my original equations and I'm basically going to do the same thing again. So this time I'm going to take the bottom two equations. So in the first example here, I took the first two equations. So I could call them 1 and 2. So I've taken 1 and 2 here. And in the next ones, I'm going to take 2 and 3. Now you could also pair up 1 and 3, that could be another option, but I'm going to take 2 and 3. So I'm going to write out my two equations again. So it's x over 2 minus 4y plus z over 4 is equal to 14. And my third equation is 3x minus y, which is the same as 1y, minus 4z is equal to -7. Make sure now that you cancel the same variable. I need to cancel the z again because I cancelled z originally on the left hand side. So first thing again I would do is get rid of that fraction. So I'm going to multiply across by 4 once again to get rid of the fraction of 4. I'm going to put them all over 1 to make them all fractions. 4 multiplied by x gives me 4x. Divided by the denominator of 2 is giving me 2x. I then multiply my middle fraction by 4. 4 4s are 16, so that's -16y divided by 1, which is -16y. Z over 4 multiplied by 4, so 4 multiplied by the z gives me 4z. 4 divided by 4 is giving me a +1z. And then I'm multiplying 14 by 4 once again, which is giving me 56. Okay, next thing I'm going to do, I'm going to write down my third line, which is 3x minus y minus 4z is equal to negative 7. Again, we're still trying to cancel out our z's here. I now have 1z and minus 4z. So I need to make that 1z become a 4z. So once again, I'm actually multiplying my top line again by 4. So I'm multiplying across that line by 4. I get 2 4s are 8x. 16 by 4 is giving me negative 64. Y plus 4 by 1 is 4z. And 4 56s are giving me 224. And that's all over my 3x minus y minus 4z is equal to negative 7. You can see here now I have a plus 4z and a minus 4z, so they will cancel out. 8x and 3x is giving me 11x. Minus 64 and minus y is giving me minus 65y equal to 224 minus 7 is giving me 217. So we're into quite large numbers here. So now I've got two equations with two variables. I have the one I solved on the left, and I now have this one here on the right. I now solve those as I normally would with simultaneous equations with two variables. So I'm going to bring both of those up, those two equations, and solve them. So I have 4x minus 15y is equal to 53, and I have 11x minus 65y, so quite large numbers here, equals 217. I now need to cancel out the x's and the y's. So if I'm focusing in on cancelling the y's, I'm going to find what the factors of, well, what can I divide 15 and 65 into, and they will both divide into 195. So I need to multiply to get 65 to become 195. I need to multiply the bottom line by a 3, and to get 15 into 195, I need to multiply the top line by a 13. So 4 multiplied by 13 is giving me 52. X. 15 by 13, as we said, is giving me my 195. And 53 multiplied by 13 is giving me 689. On the bottom, 3 multiplied by 11x, 33x. 3 multiplied by 65, negative 195y. 3 multiplied by 217 is 651. Draw your line underneath. You now want to cancel out those y's. First thing you see is that they still have the same sign. One of them has to become a positive. So what do we have to do? We have to basically multiply one of those lines by a negative 1. I'm going to multiply the second line here by a negative 1. So that's leaving my top line. Remaining is 52x minus 195y is equal to 689. And I multiply the bottom line by minus 1. So 33 by a minus gives me negative 33x. Minus 195 by minus gives me a positive 195. Minus by minus is plus. And 651 multiplied by a negative is negative 651. Now you have the y's both 195, one negative, one positive. So minus 195 plus 195 is 0. 52 take away 33 is giving me 19x. And 689 minus 651 is giving me 38. So that means if I divide both sides by 19, we are finding our x to equal 2. So we're a third of the way there. We have one of our variables. We've now found x to be 2. Now we want to basically do the same thing again here with our two variables and solve this time for y. Okay, so we found x, we now need to find y. Now some of you out there might be used to subbing in method. I'm going to solve it the old-fashioned way here. I'm going to cancel them out. So I'm going to write down my two equations once again. 4x minus 15y equals 53. 11x minus 65y equals 217. That's meant to be a 3 there. Here we're looking for what 4 and 11 will divide into. Well, I'm going to 44. So I need to multiply the top line. How many times does 4 divide into 44? It divides in 11 times. So I'm multiplying the top line by 11. And on the bottom, to get 44 out of 11, I'm multiplying it by 4. So multiplying that top line by 11, 4 11s, 44 as we said. That's meant to be an x. Let me just get my rubber. Minus 15 multiplied by 11 is giving me 165. And 53 multiplied by 11 is 583. On the bottom now, I'm multiplying 4 by 11 gives me 44x. 4 multiplied by 65 is giving me 260. And 217 multiplied by 4 is 868. Again, I want to cancel the x's. They are both positives, so I need to make one of them a negative. So I need to multiply either the top line or the bottom line by -1. I'm going to multiply the top line by -1 because it has the lower values of numbers. So I don't want to leave myself with negatives. So I multiply the top line by a negative. That's giving me minus 44x. Minus by minus gives me a plus 165y and a minus 583. My bottom line stays the same as 44x minus 260y equals 868. Hopefully that's okay. Draw your line underneath. You will now see that I have minus 44. Oops, sorry about that. Minus 44 plus 60 or plus 44, which will cancel out. They will become 0. I now have 165 minus 260 is giving me negative 95y. And minus 583 minus 868, or sorry, plus 868, my fault, is giving me positive 285. I divide both sides by minus 95, which is giving me 1y is equal to 285 divided by minus 95, which is giving me negative 3. So there's my second variable. I have y is equal to minus 3. So let's just see where we are. Let's zoom out of this if I can. So this is where we're at. We've got our x variable over here. We've got our y variable over here. We've got two of our variables. Don't forget, the question is asking us to find the three variables. It's asking us to get the value of x, y, and z. We've got our x, we've got our y. Now we have to find z. So my final step here is solving for z. And in order to find z, it's quite straightforward. You take your two values for x and y and you sub them in to any one of the three equations at the start. Doesn't matter which one of the three equations you take. I'm going to take the first equation. It has the smallest numbers and it doesn't have any fractions. So I'm going to take that that first equation there, which is giving me, let me just zoom back out so I can write it down. So it's 2x plus y. So now we want to find y, or sorry, z I should say. And I'm taking the first equation. Remember that you can take any one of the three. And I'm going to sub in my answer for x. I'm going to sub in my answer for y. And I'm trying to solve for z. When I put in my x, it's positive 2. When I put in my y, it's negative 3. 2 2s are 4. Positive 1 multiplied by minus 3 is giving me negative 3. Minus z is equal to minus 3. 4 take away 3 is giving me 1. Subtract z is equal to negative 3. Minus 1 from each side, or move over the 1, whichever way you're used to doing it, is minus z is equal to negative 3 take 1. So that's giving me negative z is equal to minus 4. You can then just change the signs. or divide across by -1, but in either way, z is equal to 4. So there's our third variable. Z is equal to 4. Now, if the question asked you verify your solutions, it's basically asking you to sub them into your three equations. I'm just going to do it for one of my lines. I'm going to take the 3x minus y minus 4z is equal to -7. I'm just going to verify it on one of them just to save us a wee bit of time here. So if I just scroll up here, I have 3 times my x minus my y minus 4 times my z equals -7. I'm subbing in 2 for x, minus 3 for y, and I'm subbing in 4 for z. 3 2's are 6, minus minus becomes a +3, minus 4 by +4 is giving me -16, and I'm trying to verify that that's equal to -7. 6 plus 3 is 9, minus 16 is equal to -7, and then you should see that 9 take away 16 is -7, is equal to -7, so we have one of them verified. You can verify the other two yourself. You should be able to prove that you get equal to -7, 14 and -3 as per the very start of the question. I'm just going to zoom out here unless someone wants to take maybe a photograph of it. They're quite long, but hopefully it helps. Thank you for watching another tutorial video from Tulla Maths. Make sure and subscribe.